In this one, we want to look at evaluating the limit of a function graphically. And so we have a graph here. This is t on the horizontal axis. Again, this is just the process you want to go through every time. On the horizontal independent axis, you have t. This function p depends on t. That's all it means. It could be y versus x, but this is instead p versus t. Okay? We're given some values. I don't really care what the numbers are. It doesn't matter. 14.5, 16, 17, great. On the horizontal, 100 to 200. Awesome. Now, what really is interesting is that this is a discontinuous function. We can see that because it is not. It does not continue. There's this jump here, and so that's a discontinuity. We call it a jump discontinuity, and so it is evaluated. The function is this. It's a 200 from 0 to 14.5. Great. And then it does this weird thing. Okay, I don't really care because they're asking us to find the limit. But it's good to just familiarize yourself with what the function's doing. That's the process here before you even look at what they're asking. So then you say evaluate. That means calculate or figure out, essentially. And so we're looking at a bunch of different limits. And it looks complicated at first, but you just want to break this down if you've never seen a limit before. And so break it down into 3 parts. The first part is lim. It means the limit. And all it says is take the limit of this function, number 2. So take the limit of this function, but then for what? There's still missing information. Take the limit of this function as t goes to 14.5 from the left side. So we got a few things going on here. But this thing down here is the third thing you look at. And so limit, that's the easy part, of a function. Great. Sometimes you'll be given the actual function, not just the graphical form. Algebraically is what I mean. And then t as t goes to 14.5, but this little minus sign up here means from the left side only. So I don't care about the right side. We'll look at that in the next one. The limit of p of t as t goes to 14.5 from the left side. That's how you say this in words. That's what it means. Let's look at the graph. This thing is equal to, these are all equal to something, and we're going to find out. But the limit as p of t, okay, the limit means as we get really, really, really close to some value. Which value? 14.5 from the left side. The left side of 14.5 is here. As we cross and we go, okay, what happens to this function as it gets really, really close to 14.5? Well, it's equal to 200. It's not exactly equal to 200 because there's a hole here, but as you get really, really close, imagine moving in as close as possible to 14.5. T equals 14.5. You're going to get the value 200. That's what our axis tells us here. Okay, so this process is the same for all of them. Well, the next one at least, and then we'll look at the rest of them. So part B, the limit. It's the first part, the limit, or as we get really, really close to some value, the limit of, well, the function as t gets really close to 14.5. But now from the right side. So this time we're going from the right side, or as t approaches from the right. And so we can see, oh, like we get really, really close here. As we get really close, we can see, oh, as we get really, really close, not exactly 14.5. Imagine 14.5001. That's pretty dang close to 14.5. What about 14.50000 forever? 1. That's what we're talking about here. And so this thing, we just look at our graph, it's equal to 100. So it's actually pretty easy, but you really do want to understand what's actually happening here. When you have the graph, it is very easy, though. You just simply look at what it gets close to. Now, the tricky part that you want to look at here is, all right, part C, we got the limit. Fine, the limit as what? The function approaches 14.5. Notice we don't have a minus. We don't have a plus up here like we did before, meaning the left and right sides. But now this thing, what is it? Well, I'm going to tell you right now, this thing does not exist. And the only reason is because these two things are not equal. Let's go to a new page here. And so in general, the definition of a limit, the limit as x goes to some value, let's call it 0, for this thing to be defined, if it is defined, that's what DNE on the previous page means. If it is defined, the left-handed limit as x goes to 0 from the left side of f of x, better be equal to this right-sided limit, we call it, as you go to 0 from the right side. If these things are not equal, a big old slash through the equal sign, this thing does not exist. DNE does not exist if that is true. Well, let's look. Is the left-sided limit of t of this whole thing, t goes to 14.5 of p of t, from the left side, is that equal to the right side? Well, here's the left side, 200. Here's the right side, 100. Obviously, 100 is not equal to 200. 100 is only equal to 100. It's not equal to 200, so the limit doesn't exist. Okay, so that's a really crucial part there. So for the last one, you want to evaluate the function. Remember this functional notation p of 14.5. You're substituting the value t equals 14.5 into the function p. Well, we're given the graph, and so is it defined at 100? Yeah. It's got a closed circle here at 14.5, so the value is simply equal to 100.